How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at some practice problems for 21.3 nuclear transmutations. So what is needed in order for a nuclear transmutation to occur? So generally, when we're talking about nuclear transmutation, instead of like natural decay, we're talking about transmutations where we have caused it to occur. So typically, you need a particle to collide with a nucleus. So we kind of usually start with like a larger nucleus, and we shoot it with a tiny particle bullet, maybe a neutron or something, which is going to cause that large nuclei to split apart into smaller nuclei and maybe some other particles too as well, giving us new elements. Number two, what is the product of the following nuclear transmutation? So, you know what, I'm going to write it out bigger over here. So we got Pu 239 being bombarded with an alpha particle, and when that happens, it's going to give off a neutron and some missing product. So again, we got to look at the balancing the masses and the charges. Oh, why don't I start on top with the mass? I have 239 and 4 on the left side, so I have a total of 243 as my mass on the left, which means my neutron giving me 1, and what's the missing mass? 242. I do the same process with the charges, 94 and 2. So on the left side, I have a charge of 96, which means I have to have a charge of 96 on the right. Well, a neutron has no charge, so the missing element has a charge of 96, which tells me that the missing element is Cm. All right, number 3, what is the missing particle in the following nuclear transmutation? So same process. If I take a look at the masses, I have 14 and 1 has to equal 1 and some missing thing. Guess what? The missing thing is 14. All right, do the same thing with the charges. 7 plus 0 from the neutron has to equal 1 plus whatever's missing. What's missing? Well, to keep that balance, it's got to be 6. So what has a charge of 6 and a mass of 14? Carbon. So that is the missing thing. 4. When Si-28 is subjected to neutron capture and then alpha emission, what isotope is produced? All right, let's draw my arrow first. So if I have neutron capture, that means the neutron started off as a separate thing. So it's going to be on the left side, right? It's got a charge of 0, mass of 1. And it's saying Si-28 is subjected to it. So I start with Si-28. So a mass of 28. When I look up the charge for Si, it's 14. And all right, so neutron capture and then alpha emission. So I'm giving off an alpha particle, so it's got to be on the product side. And it says what isotope is produced. All right, so same process. Let me look at the mass. Mass on the left has a total of 29. So on the right, it's got to be 4 and some number. So what's that going to be? It's got to be 25. Missing mass is 25. Now let's take a look at the charge. 14 and 0 gives me 14. So on the right side, 2 and some number has to give me 14. The missing number must be 12. So what element is that? It is magnesium. All right, number 5. If cobalt-60 is made by neutron capture, followed by beta emission, and then another neutron capture, what is the nuclide you start with? Okay, so let's, again, draw the arrow. And it's saying we're making cobalt-60, so it's a product. Cobalt with a mass of 60. I look up what's the charge of cobalt. It's 27. It's made by neutron capture, so I have a neutron being captured. Had to be a reactant, followed by a beta emission. So if I'm emitting it, it is now a product. So it gives off a beta particle. And then another neutron capture. Interesting. So I could write this out again, or I could just put a coefficient of 2 in front of the neutron. It says, what is the nuclide that you start with? All right. Same process that we've been doing. Right now, I have some number on the left plus 2 times 1. So I have a mass of 2 and some number. Has to equal on the right 60 plus 0. So what's that some number got to be? It's got to be 58. All right, do the same process with the charges. I have 2 times 0 from the neutron, so I have 0, and some number has to equal, well, let's see, 27 minus 1, so that's really 26. So what's my missing charge on the left? 26. So what element has a nuclear charge of 26? It's iron, Fe. So the missing reactant would be Fe58. All right, I hope you found that helpful. I'll see you in class. Goodbye.